Hello and welcome. So here's our video on Chapter 6F on division with decimals. It's not too difficult, it just involves mostly arithmetic and a couple of tricks here and there. So our objective, you can find them on page 350. We just got a couple of things to do. Can we divide by a whole number, and can we divide by other decimals? That's basically our objective. So I do want to cast our memory back to when we had the rules about how to multiply with decimals. I'm doing this up front, one as a refresh, and also two, I'm hoping that you'll see how the division with decimals is slightly different. So you don't mix them up. You don't mix up the rules or the tricks. Okay, so I've just got a couple of problems here. One where I've divided I've got a decimal number and I've divided by a whole number. Multiplied by a whole number. And you recall the process where we basically pretend that that decimal place doesn't exist. You carry out the problem, and then I can now take this result, move it back up over here, and I restore the decimal place. So let me just quickly write this one out. Since I moved it back 1, 2, 3 spaces, I need to move this one 1, 2, 3 spaces. So the answer should be 15.060 for that one. Now I've already sort of done this ahead of time. But the other one, a little bit more interesting, here I've moved this one back 2 spaces and this one as well backwards by 2 spaces. So when I've done my problem here, I get a result here, which I can copy, paste right there. As I bring that answer into my solution. But I need to restore the decimal place by moving it this direction by 4 spaces. So if I do that, I do need to put the decimal point right in front of the 9 here. So I do need to introduce a empty 0 at the very front of the line here for it to make sense. It's 0.9756. Okay. And does that make sense with what the original question looks like? So we've got roughly 3, and then we are multiplying it by about 33%. So we're looking at a third of a 3, which is just a bit under a 1. So yeah, it seems to line up nicely. So that was the trick, where we just basically pretended the decimal place doesn't exist, and we achieved this by moving it back to the end of the line temporarily, and then we restore the decimal point at the very end when we're finished. When it comes to dividing decimals by a whole number, we can just use short division. So you just jump straight into it. So I've got this purple 524, and I'm going to divide it with 4. So does 4 fit into 6? It fits in there once with 2 remainders. 4 fits into 20 5 times with no remainders. Yeah, 5 times 4 was 20, yep. 4 goes into 5, fits there once. I got to carry my decimal point up here, so there it is. So 4 fits into 5 once, and it has 1 left over. 4 goes into 12 exactly 3 times. 4 goes into 4 exactly once. So that's our actual answer there. I don't have to rewrite it all over again, but this is the answer to the problem. So that one is really easy. I think the hard case, or I guess the more interesting case, is when you divide a decimal by another decimal. Okay, so here's the example. I've got 24.562 divided by 0.02. So I'm going to show you how this can be solved using fractions form and then short division. Once you see that, I think you'll understand why the shortcut trick works, where it's coming from, okay? So you may recall that from previous lessons that the division symbol can basically be, so if I've got 4 divided by 5, that's the same thing as 4 over a 5. So the fraction form is another way of expressing a division symbol, is what I'm trying to get at here. So if I use that, so that's what I've done over here. I've just copied it down. So it's the exact same question as before. It's still this question. I've just copied it there. And I've just reformatted it into a fraction form. Now this does look strange because a fraction is not supposed to have decimal places. So you want to get rid of those. I don't have to get rid of all the decimals for this trick to work. All I need to do is make sure that my denominator, its decimal place has to go all the way to the end, ideally such that I'm left with just a single digit on the bottom of my fraction. So you're familiar with equivalent fractions, and that's where we scale the whole fraction up or we scale the whole fraction down, depending what we want to do. Here, I'd like to move the decimal place back twice, and to achieve that, I will need to multiply the denominator by 100 to move it back 2 spaces, and to keep it same to the original problem, I must scale the numerator by the same amount as well, which is also going to move the decimal place back 2 spaces. So what am I looking at now? I've got an answer. I've got a question that says 3, 4, 5, 6, 2, all over 2. Now that I've got it in this format, I think it is easier to solve in short division. So I would just punch it through short division. So it would be 2 outside of 2, 4, 5, 6 dot 2. 2 goes into 2 once, 2 goes into 4 twice, 2 goes into 5 twice, 1 remainder. 2 goes into 16 8 times, nice and clean. Bring up my decimal place. 2 goes into 2 perfectly, so that's once. So my answer is that. Now, the fraction method does sort of have a bit of, writing involved, but the shortcut that we want to use, which I've got here in purple, is we're basically going to be capturing this step in here. So we don't have to do a lot of writing. All we're going to do is, I'll leave that highlighted actually. That bit is what I'm going to achieve here in purple. I'm just going to move the decimal place back 2 spaces. Move this one back 2 spaces. Why? Actually, the clincher is that let me see if I can articulate this. This has to be the same amount as this for the trick to work. Okay? So unlike with multiplication, where I would have to move this one all the way to the end, this will be 3 spaces, and this one will be 2 spaces. That would be the case if it was a multiplication problem. However, with division problem, the rules are slightly different. All we need to do is make sure that this decimal place of the divisor moves to the end of the line, so I'm left with a single number. It's nice and simple. And I must match how many spaces I've moved back. So I moved it back twice, so I'll move this one back twice. They must be the same amount for both of these numbers. Now we can write the question as 2, 4, 5, 6 dot 2 divided by 2, and we should, and we have that short division process, which is basically that one. I can just stick it over here, and it'll be the same result. Okay, so this purple solution is the way that I would recommend doing these divisions with decimal numbers. Just make sure you're pushing the decimal place equivalently between these two numbers and you'll be fine. Let's look at a different scenario. So the original question here, the divisor, this red number, is less than 0. So it's 0.0 something. We can also use this method if it is above, if it has lots of zeros trailing behind it. So what we're going to do in this occasion here is, instead of moving the decimal place backwards like the previous example, I'm going to move it forwards such that I leave just 1 digit as my divisor, and that's easier to solve. So I'm going to move this one forwards 3 spaces, and I must, for this trick to work, I must do the same to both of this number and this number. So I'm going to move this one forwards 3 spaces as well. So my question is going to become 0.1498 divided by 7. And it is equal to the original. Because again, if you recall that, I can show that fraction step in between if you really want. So this, let me go with this, copy, paste. So essentially what we've got here is I've turned this into a fraction sign, and we're going to get a pretty small answer. 150 divided by 7,000 is going to be a pretty small number. So that kind of matches what we got down here when we done our conversion step here. We got a very small number divided by 7. So I think we're heading the same direction. Let me just backtrack to make it all nice and neat again. Right. Once we get to there, now we can finish the problem off using short division. So I can put my equal sign down there. Here's my 7, goes into my decimal number. Oops, there we go. Now just quickly put it together. Let me go with, I think I'll go with purple. 7 doesn't go into 0. 7 doesn't go into 1. 7 goes into 14 twice, nice and clean, no leftovers. 7 goes into 9, fits in there once with 2 leftovers. 7 goes into 28 4 times, I think. Let's see, 7, 14, 14 times 2 is 28. Yep. So my answer is 0.0124, I think. That's the bit I hadn't written in earlier, as I forgot to put in these zeros here onto my solution. So there we go. If I'm going to write it out nice and clean, I would say the answer is 0.0214. And if I really want to check, I can just ask Siri to confirm if that's true. So let's see a little bit of a video clip. So that's how you can do it when we got 2 decimals and you've got a division problem going on. Now I realize if you're just watching from YouTube and you're not in my classroom, then you wouldn't have seen all the different lessons we've had previously about decimals and adding and subtracting and all that sort of stuff. But my students at the moment, we should have covered all the basics, so adding, subtracting, multiplying, and division with decimals. So now we can do one of these big, ugly order of operations problems, or I've been calling them BOMDAS or PEMDAS problems, where there's several things in a row that we need to solve, and they all involve some sort of tricks that's with decimals. So let's see if I can solve this one. I haven't had a chance to try it yet. My first thought should be, well, it's order of operations, so where must I begin? What has the highest priority? Well, I can see there's a division symbol and a multiplication symbol and a division symbol. Which one of those do I do first? They're basically the same rank of importance or priority, so I'll actually choose the left one first. So I'm actually going to go with a multiplication step first. So let's quickly solve that. So we got 3.8 take away. Now the process for doing that is to pretend the decimals don't exist. This is going to get a bit messy now that I think about it. So how am I going to incorporate that into my bigger solve? So what I might do is this is just some layout nuance. Let me just see if I can clean this up so you can see where I'm. Okay, so on this side, I'm doing my arithmetic. Okay, but this is my solution. Okay, so this area here, I want to keep the whole problem intact. I don't want to cut it out into pieces. However, to solve this piece, I will need to do a little bit of arithmetic, and I prefer to keep that off to the side, particularly because we have established, this process where I need to restore the decimal place at the very end. So that's what I'm going to do over here. So I'll do the 1.6 times by 45. So here we go. 5 times 6 is 30. 5 times 1 is 5. 5 plus 3 is 8. Put down my 0 because I'm doing 40 times 6 now. 4 times 6, 12, 20, 24. 4 times 1 is 4, plus the 2 I've saved, that's 6. Add them together. Quickly check that I've done that correctly on video. but it is part of the arithmetic we need to use to finish the problem. So I'll put that in here now in blue. 720. I need to restore the decimal place because I originally ignored them. So I moved this one back once. I moved this one back twice. That's a total of 3 spaces. I need to move it forwards 3 spaces. So it's going to be 0.720. So that bit there is solved. Now I can just copy down the bits that I haven't worked with yet. Now we run the BOMDAS protocol one more time. So what's the highest priority out of subtraction, addition, or multiplication? I think we can all identify that it's going to be this one. That's going to be the important one to solve now. So we've got 5 divided by 0.4. So this one, I am going to use the trick where I'm going to move the decimal place backwards such that my dividing term is only 1 digit long. And for this trick to work, I must do it the same to both of them. So that decimal point is also going to go backwards. So that is going to be, and this one will be identical to the answer above, so I can keep using that. So this is now 50 divided by 4. And I can use short division to finish that one. Let me just use this edge here as for my arithmetic. So that'll be 4 goes into 50, fits 4 goes into 5 once with 1 left over. 4 goes into 10 twice with 2 leftovers. 4 goes into 20 exactly 5 times, and I put my decimal point up here. So the answer is 12.5. Here's my 12.5. Because I can bring that number and now put it here. Now what's next? I think we just got adding and subtracting to finish the solve. So I'm just wondering, can I do it all in one hit? There's a higher chance of me making a mistake, particularly in video, but if I'm trying to do 3 things at once, I will tend to make mistakes. But, so what we might do is we might change this. This will still be equal because I can still incorporate all this. So I could have 3.8 plus 0.720. So when you recall when we're adding or subtracting decimals, we need to make sure that these line up. Actually, this was supposed to be a subtraction problem here, so that was a mistake already on my part. And I have to introduce some empty zeros here for everything to work properly. Once I get an answer down here, I'll then add this bit to the bottom here. So let's see how I go. 0 take 0, 0. 0 take 2, can't be done, so I need to borrow from here. That drops down to a 7, that makes a 10. 10 take 2, 8. 7 take 7, 0. 3 take 0, 3. Now I can introduce the adding the 12.5, so add 12.5 to finish the problem. I should get, and I've got some empty zeros that I can add on there. 0 plus 0, 8 plus 0, 0 plus 5, 3 plus 2, and then the 1. So that should be the final answer. And I can try asking Siri if she will confirm if this is the correct answer. Let me try. Excellent. So that is basically it, students. The trick is particularly dividing with a decimal. Decimal divide decimal. You need to push the decimal point in the same amount for both of those items and then use short division. I'll end the video there and I wish you good luck.